This is Prantij 3.7 MLD CAMUS type STP. This is the inlet side. The flow meter is on our screen. This is the stilling chamber. The wet well is currently in the middle of the day not working. So as soon as the morning flows come, the inlet stilling chamber passes wastewater through the mechanical screen on the right and manual screen on the left. The floating debris, plastics and other screening activities are removed on this platform. The equalization tank then handles the peak flow of the inlet sewage and holds it so that the rest of the plant can operate at average flow. That is the equalization tank, and as you can see now, the wet well has started and the screened raw water is being put into the equalization tank, and the pump from the equalization tank is transferring wastewater to the tube settler. The tube settler puts water and as you can see here, the clarified water from the tube settler is coming, and the clarified water is being transferred to the biomounts using this header pipeline. The first biomount is called BM1. The second biomount is called BM2. This is biomount 1, which is the nitrifying reactor, and as you can see it is fairly green. And biomount 1 also has a sludge vermicomposting bed. The vermicomposting bed takes sludge from the bottom of the tube settler there, and then converts it into vermicompost, therefore creating very little sludge output for the plant. This is biomount 2. The plantation is looking very green and nice, and the treated water from biomount 2 goes to CCT, or the chlorine contact tank. Here is CT1, which is the nitrified water. The nitrified water is pumped partially into BM2 using pumps in that location, and the mixture of nitrified and ammoniacal water directly from the tube settler top is a denitrifying mixture where N2 gas and H2O and oxygen is produced. The final part of the treatment process is the disinfection process. As you can see, this pipe, the UPVC pipe, is connected to the chlorine gas chlorinator, which is for disinfection. And post disinfection, the chlorinated water is allowed to pass through this chlorine contact tank via this baffle arrangement, and the final treated water is available for sampling, and the final treated water is also measured using the partial flume for flow measurement, which is reported in the SCADA. Water quality of the CAMUS system is exceptional, meeting all NGT 2019 norms with very little power consumption and very little smell and ease of operations. This is the SCADA based system that mentions the flow from the wet well and the rising main. It goes into inlet screening chamber. The manual fine screen and mechanical fine screen exist. Currently flow is not there. The water then goes into the equalization tank via level sensors into the tube settlers 1 and 2. The sludge from the tube settler is heading into the vermicomposting bed, and composted solids go out. From the top of the tube settlers, the water partially goes into biomount 1 and goes into collection tank, which is biomount 1 creates nitrifying water, and that is then mixed with the ammoniacal water from the tube settler into biomount 2. Post biomount 2, the outlet of biomount 2 then goes into the chlorination tank, and post the chlorination tank has a recirculating pump and it goes through a partial flume. Post that, it goes into the disposal chamber and into a nearby pond or receiving water body. As you can see here, the outlet is working at 195 or 190 cubic meters per hour, and that is going for disposal as per the. I'm just this video is to show the flow meter, and we will do this for 30 seconds to see how much flow is going through the plant at the end partial flow. So this is the progression of treatment. On the left is the water in the equalization tank. In the next one is the clarified water from the tube settler. The third one is the CT1 water, nitrified water, and the last one is the treated water from the process. This is the electricity bill for the plant, and on average apparently here approximately 1 mld per day is being treated, but at the designed flow. So the monthly bill for treating 1 mld of wastewater for the entire plant including all services is approximately 12,000 rupees per month. This is the actual flow of the plant and the power consumptions for the last month of March and for the month of April as of date.